We present code space, combining touch, devices, and skeletal tracking to support developer meetings. CodeSpace enables cross-device interactions, or multimodal input techniques that combine in-air pointing and postures, physical proximity, direct touch input, and motion sensing input channels together into a single interaction. CodeSpace builds on the code bubbles visualization metaphor, in which individual methods, bug reports, sticky notes, and diagrams are displayed in individual bubbles that can be moved and manipulated with touch. Users can pinch to zoom the workspace or an individual bubble. Touch dragging on the background pans a virtual workspace, while touch dragging on a bubble moves that individual bubble. Users can also write on top of the bubbles using digital ink, much like they would on a traditional whiteboard. Our goal is to allow developers to easily bring digital artifacts into a whiteboarding experience and then annotate them as needed. Users are free to ink in the space between bubbles to indicate relationships, or over individual bubbles to highlight specific features. Many development meetings focus on categorizing or prioritizing a set of items, such as bugs. Workflow templates allow developers to add the lightweight structure of visual buckets to aid in categorizing items. Multiple template configurations are available, and since they are not tied to specific tasks, users can appropriate them as needed. When an audience member points at the display, skeletal tracking identifies a gesture and displays a cursor on the shared display, allowing them to point out precise locations to the group. Audience members can also manipulate objects by forming a flat palm posture with their hand, switching the system into drag mode. Objects under the cursor will now be dragged with the user's hand motion until released. Audience members can also use a mobile phone to interact with the shared display. Users may point the phone at the display much like a remote control, showing a cursor. To drag items, instead of changing hand posture, users can touch down on the phone to drag. We explored phone manipulation as an alternative to hand posture manipulation for users who brought a smartphone with them. To augment pointing, the user can also add temporary ink using their phone. By pressing and holding an ink icon on the phone while pointing in the air, they can highlight regions of interest. Because the ink is of low precision, we clear it on release. Users can execute commands from the audience by pointing the phone at the display and gesturing. In this case, the user performs flick gestures to pan the display to access content that is off the screen. Users can also pull content down onto their phones to view or edit locally. The user points the phone at an object they would like to pull, and then flicks down to pull the object onto the phone. Once the object has been transferred, the user can resize and manipulate it locally. In this case, it is a bug, and so the user chooses to edit its priority and status. The saved changes will be reflected on both the phone and shared display. Users can perform the reverse gesture to push content to the shared display. Users felt that presenters should be given the ability to preview content before accepting it into their presentation. To support this, content sent to the shared display will initially appear as a package. The presenter can then hover over the package for a preview and then tap to open it. Users may want to briefly show an object to the group, the equivalent of holding up a piece of paper to share. By combining the phone's accelerometers with skeletal tracking, users can hold up the phone to transiently share for as long as the phone is held up. The presenter can tear off the shared content to make it a permanent part of the display, otherwise it will be dismissed when the user puts their phone down. Users can also transfer content to a touch-enabled laptop. Pointing at the shared display specifies what to transfer and also puts the laptop into gesture mode as indicated by a screen overlay which also shows the available gestures. The user can then swipe down on the location they would like to place an object. Working locally, the user takes advantage of the keyboard. The user then performs a reverse gesture to share their work with the group. In this case, no presenter is present at the display, so the package opens implicitly. Users can also take advantage of people tracking by pointing a phone at another user and then flicking up to share with them. We also provide users with a passive tertiary display that extends above the region comfortably reachable with direct touch. Users can then send content to the tertiary display from the shared display by pointing at it and then flicking up on the objects to send. Because users can pan and zoom the shared display, this creates the potential for contention issues with two or more presenters. We automatically split the display in place when multiple presenters are present to give each user a separate view of the same underlying content. Toolbars can be ineffective on large displays as they may require users to walk to reach distant commands. We explore posture-invoked tool palettes. To open a posture palette in situ, the user simply forms an open palm posture in front of the display. The palette will track the position of the user's hand and is dismissed when they stop forming the posture. Another advantage of using the hover state is that users do not need to touch the screen to open the palette, which helps to minimize the chance of accidentally selecting objects. Users can also use posture to enter gesture mode on the shared display. We use the same posture to minimize approachability issues. Users can gesture freely on the canvas while the posture is open to invoke commands. The set of mark-based commands is disclosed using a marking menu when the user dwells at the beginning of an input stroke. Here we see the user step through code using the debugger with gestures. We also include a scribble gesture which the user can use to erase the display. We have presented CodeSpace, a system for supporting co-located small group developer meetings by democratizing access, control, and sharing of information across multiple devices and shared displays.